Hello, everyone. Welcome to this second webinar in our Green Shoots series. People are slowly joining this webinar now, but we are very, very excited to have you all present today. Some people might have seen the first one, and for those who haven't and are new, welcome. Very excited to have you. And just as a bit of intro, in this webinar, we'll be highlighting the diversity of the research and the researchers that we have in a project called Wildy. With us today are Martin Miklas and Rian Anglor, who are both from the Czech University of Life Sciences, and they will speak a bit later on their research and talk a bit more about the forest in the Romanian Carpathians. But first, quickly as a bit of a reminder, what is Wildy actually? Well, Wildy is a project funded by the European Union that looks at rewilding as a climate smart solution to both the climate as well as the biodiversity crisis. And in this project, we look at climate smart rewilding at 8 different sites across Europe, assessing the rewilding approach and seeing how people do it and what lessons can we learn. And in this project, we are very happy to have a group of over more than 15 young researchers and PhDs, and we are very excited to show some of the work that they're doing. And in this webinar, we will present this work today, Rhiannon and Martin, but in the future, others. So if you like today, please join also the other ones that we will be hosting over time. In this presentation later on, there will be time to ask questions. If you have any questions, please put it in the Zoom chat, as also just mentioned there, and we'll address them at the end of the presentation. Also know that this webinar will be recorded and will be posted later online if you would like to review it. But with that, we have two people here who both get to spend a lot of time in the beautiful forests of the Carpathian Mountains, and I've already seen that they have a beautiful presentation with some pictures of that beautiful place. So with that, I give the floor to Rhiannon. Please, could you start us off today?
Yeah, thank you for the introduction. Good morning, everyone. My name is Rian Anglor. I am a PhD student at the Czech University of Life Science, and we are working under the project named Remote, where we, as Tim said, are lucky enough to investigate what's happening and the growth patterns in the primary forest, especially across the Carpathian region in Europe. So this is what we'll talk about today, to give you guys some background information on the distribution and the value of these primary forests and the conservation issues that's affecting these last wilderness areas of Europe. So as some quick background information, what actually are primary forests? As I said, they're some of the last pristine forest ecosystems of temperate Europe. And these are forests that have developed without any direct human intervention. So that means these forests still maintain their natural stand composition. They've got a mixture of trees of different ages and sizes, and especially many old trees. And all this leads to high diversity in vertical and horizontal structure, including many structures not found in managed forests, such as standing and lying deadwood. And importantly, these forests have developed naturally, so that means that natural disturbance regimes are some of the main driving forces for driving the structure. And that means that these primary forests can come in all different shapes and sizes, including younger looking forests, older forests, and everything in between. So to give you guys an idea, this is one beautiful forest in the Slovakian portion of the Carpathian Mountains, and this tree has been dated to possibly around 1,000 years old. And obviously this is very rare across the European landscape now, so it's wonderful to see such trees still existing. This is a lovely example in the Făgăraș Mountains of Romania, where there is many valleys still quite untouched and retain these primary and old growth forests. So what is quite special is that you can see the natural distribution of tree species along the valley, So it starts with a mixture of beech at lower elevations and transitions to spruce at on the upper slopes. And again, you can see the beautiful diversity of tree species here, mixed beech and fir, and lots of standing inline deadwood present. And so, of course, these forests also are home to some very rare and endangered species that are very reliant on these structures and cannot maintain suitable populations elsewhere, such as the Eurasian lynx, the bear, the wolves, and many different bird species. So we know that some of these forests exist, but it's still quite an under-researched area. So one of the biggest studies that came out in 2018 by Francesco Sabatini and his team used literature to map the distribution of primary forests across Europe. And with this, they found that across 32 countries, there was over 1.4 million hectares of primary forest still existing. And although this sounds like quite a lot, this actually only constitutes just 0.7% of Europe's total forested area, which is not a lot, right? And under half of this is actually receiving strict protection. So that means that human management can still occur within these forests, including salvage logging. And this study also found a distinct clustered pattern across the Carpathian Mountains, which spread from Central to Southeastern Europe. And this is the focus of the presentation today, to talk about these important area of forest. So as I said, it's still quite an understudied area, and although this study was excellent to give some insights, it was based on literature, and unfortunately many of these primary forests are still not mapped and identified, and it's actually quite unknown, like the true distribution of these forests. Especially in Romania, there's many areas that from our research, we are able to confirm that they're containing all of the structures necessary to be defined as primary forests. As you can see here, some beautiful lying and standing dead trees. Yeah, lots of different species and size distribution. And also many rare and endangered species have been found in these forests. But yes, unfortunately, they're still not included in the catalogue of primary forests under the Romanian government. This is a very nice picture. I don't know if you guys can spot anything interesting, but if you look a little closer, you can see a little head next to this large fir tree. And when you zoom, you can see it's actually a bear watching us work in the forest. And you can really see like the size of this tree from this photo, right? Like how tiny this large bear looks in comparison. And yeah, this is just a nice example of what you can find in these areas. Again, some lovely photos, which I guess is not very common to see in forests these days, and many of you may have not seen such beautiful areas. In Romania, again, the Carpathian Mountains, actually, thanks to our research, one of these unmapped valleys actually received protection now, and this is a very special valley which we were lucky enough to spend some time in. There's 10 kilometers of valley without any road access, any human intervention whatsoever, and it's one of the last remaining true wilderness, truly wild valleys in Europe, and it's a very special place, and thankfully now it's protected, but the neighboring valleys are not so much. And yeah, again, some nice examples of how these forests look, and how in this valley in particular contains many old trees exceeding 300 years old. It's great that it's finally received protection. However, yeah, not all forests are protected yet, but thankfully in Slovakia, my colleague who will take over, he helped to map the entire country to try to detect where the primary forests are, and using ground level data, they found over 261 primary forest localities across the nation. And again, although this may sound like a lot, it represents less than 0.5% of the total forested area of the country, which is just 0.21% of the entirety of the Slovak Republic. So it's not a lot. It's very small clusters are remaining. And as you can see, that the distribution is quite grouped into certain areas. So the study went further to try to find out what was driving this clustered pattern across the landscape, as in what environmental factors have led to the survival of these forests. And they found that these forests were much more frequent in areas of higher elevation, with steeper slope, greater distance from roads and settlements. So essentially areas that were inaccessible to humans in the past using less modern technologies. So you can say remote locations, and that helps to protect them from deforestation. But this can change in the future as technology is developing. Okay, we can see that these forests are beautiful and they're quite rare, but they can also offer quite a lot to science. Because they've developed without human intervention, they're essentially these living laboratories that provide valuable reference sites for foresters. So when we can understand the processes occurring within these forests, we can mimic them in our managed forest and try to work towards more sustainable practices based on these natural growth dynamics of forests. And this is part of our remote project. This is especially important as we consider the effects of climate change that we know is happening these days despite the uncertainties. This is quite a nice study that came out a few years ago that used 1,000 years of wood samples to trace the climatic patterns occurring deep into the past. And we can see that although fluctuations in temperature was quite common throughout this 1,000 years, there's a distinct peak starting from around 1950s to present day. And this is all leading to an increase in forest disturbances as the temperatures are increasing. Forest fires have also increased, the extent of bark beetle outbreaks and windstorms. And this is actually predicted to increase with the future. And the question is how primary forests will react to this. But we also want to answer the question, are this increase in forest disturbances only the result of climate change, or are other processes also driving this recent increase in disturbances? And this is a very important component of our project. We use dendrochronological data to go back into the past and find out if natural disturbances are a natural part of forests or they are increasing with climate change, and what we can find out about this to manage our forests more sustainably. So here's our website. You guys can check it out later. So as I said, the main objectives are to use tree ring-based data to understand the growth patterns of forests. How do trees live and die, and how the deadwood returns back, and then essentially how this affects carbon storage and sequestration, and also the biodiversity within these forests, and how these patterns may change across different temporal and spatial scales. So here are some photos of the fieldwork. So as I said, these forests are incredibly remote and quite difficult to access, some very steep slopes, involve some climbing and crossing some strong rivers. So it's quite an adventure to get to these sites. But when we do get there, we've established some permanent research plots across the European continent. So we return every 5 years to remeasure the plot. So we take the positions of the trees, measure the DBH, species, and extract core samples to find out what is happening over the remeasurement periods and further back in time. So yeah, nice example of a bear from our research plot. So you can get an idea of how wild these places are. Yeah, we're camping for weeks at a time, carrying all equipment to the fields. And after all this fun in the forest, we go back to the lab and process the data. So in case you guys don't know what dendrochronology is, we take a sample from the trees, which looks something like these lower photos. So you can see the tree growth patterns depending on the width of the ring. And using this information, we get a sample like this, and we can detect the growth patterns into the past of a certain tree. So as you can see with the arrow, the tree ring width gets larger than to the left of the arrow, and this indicates that this tree received elevated light resources after a sudden period, which indicates that a canopy tree died, and that's why it was able to grow faster. And when we put all this information together, using many different tree core samples, we can reconstruct the whole disturbance history of an area. And using this information, this was a very informative study that was released a few years ago that used these tree core samples across the whole Carpathian region, stretching from the Czech Republic to Romania. And what they found was quite interesting, that there was a distinct peak of disturbance events occurring around 1920, so around 100 years ago. And since then, there was a significant decline of disturbance events in these regions. And this can be attributed to tree age. So around 1920, the trees were much older and therefore much more vulnerable to disturbance events, insect infection or wind throw events. And that now in recent years, we are again seeing an increase of tree age as the forest develops, and then the trees are therefore again more vulnerable to disturbance events. So all this suggests that natural disturbances are a natural process occurring within forests, and although climate change is, of course, an issue that we must think about, we also need to include disturbances as an essential process in forest developmental cycles. So here are some examples of some disturbance. Here is in a spruce forest, you can see a distinct area affected by bark beetle outbreaks, providing lots of standing deadwood and elevated light resources. Here in a mixed forest, again, lots of fallen trees, deadwood, and changing the structure of the forest. And these disturbances can occur in all forest types. So this is a pure beech stand, which is also affected by wind throw events. And this was a photo from last year. It's in Semenic National Park in Romania, which is the largest area of beech forest in temperate Europe. And in 2023, last year, a huge area was affected by a wind throw event, and almost something that has not been seen before in the past. And it's not a normal event that we would expect, but it just shows that these disturbances can occur in all different sizes, whether just a small patch of trees or a much larger area. And all this influences the structural diversity through producing different habitat spaces. As I've said, so this means that forests can also appear young, much smaller trees here, but you can still see the deadwood on the ground, which is indicative of primary forest. Also some smaller events such as rock slides, larger rock slides, So disturbances are integral and an essential component of primary forest dynamics, and we really need to understand how this affects the communities within them. Even this tree, if you can guess, it's a bear tree. A bear was marking its territory here, and so really affected this tree, and again showing that disturbances come in all shapes and sizes with different drivers. So a big part of our project is to find out how these disturbances affect the biological communities residing within these forests, and how this can change across different spatial and temporal scales, depending on the disturbance characteristic. So we can define disturbances across by their components, such as the number of years since a disturbance event occurred, or the severity of the disturbance, which means the area affected by an event, and also the frequency, so how often these events occur. And we have looked at different taxonomic groups to see if there is any differences in how they respond to these disturbance legacies. So one study focused on lichens in primary forests, and an interesting result was that the number of threatened species declined with increasing disturbance severity. And this can be attributed to the fact that threatened lichen species are quite resilient, quite reliant on typical old growth structures, such as the presence of very large and old trees and the tree microhabitats that are associated with these structures. So they respond positively to time without a disturbance event. Whereas fungi, on the other hand, we found that the number of red-listed species increased with the frequency of disturbance events across time. So this can be attributed to the increase of dead wood in different sizes and decomposition stages. So when a disturbance occurs more frequently, more deadwood is produced, right? And this provides different substrates which change across time to support diverse communities. And finally, we found also that beetles, saprophyllid beetles that also rely on deadwood, they responded positively to the severity of the last disturbance. So they like the conditions provided by more open forests, and also the production of dead wood, large standing dead trees, and also fallen trees. So all this tells us that different components of forest communities respond to different disturbance legacies across time. So we can really go back 100 or 200 years and figure out what was happening then to actually understand how our present day forest communities are shaped because of the effect of disturbances on structure. So the management implications of all this is that we need to really think about disturbances and how processes in the past affect present day forests, and that disturbances are a critical part of forest dynamics, and they must be considered in management of our primary and also managed forests. So I will give the floor to my colleague, Martin Mikolash, now, and he will talk more about the management implications.
Yeah, thank you very much, Ria. I will try now to share my part of the presentation. Yeah, can everybody see it? Oh, yes. So thank you very much for this nice explanation of the importance of natural disturbances in driving the biodiversity of primary forests. But what is the reality? So as Ria mentioned, we spend a lot of time in the field, and of course, during our studies, we also observe not only the nice things, but especially when we come back, we also observe large-scale destruction of this unique heritage. And the main reason is often salvage logging. So it's actually not acceptance of natural disturbances as natural process that keeps maintaining the biodiversity of this forest, but oppositely, often the foresters actually are required to follow the forest law, and they can do legally they can legally actually destroy these unique ecosystems. So what we see that new roads are being built to the most remote sites. We found out logging in forests where we believe nobody will ever get when we establish the plots. You can see this example, for example, from Carpathian Mountains, where from the plot almost all the trees were logged. Trees older than 300 years were cut down. And the roads are often built from the lower elevations through mixed forest to reach the upper coniferous forest. But the new roads again allow also later on logging in this mixed forests. This is another example. It's a Belia Valley in Romania, where in 2012, where we started the research, you can see these polygons on the left side. This is all old-growth forest. When we came back in 2017, almost half of the forest was destroyed. The scale is relatively large, and the trend actually didn't stop. These are recent data from our recent survey in Romanian Carpathian Mountains in Mare, where the logging occurred just next to our plots. We also wrote an official letter to the ministry, but we don't have response. So it seems there is no really like will to protect even these scientific plots, which is actually just a small proportion of all the forests. So the situation is really bad. What is interesting that when you see the logs, they're often rotten. So this type of wood can be mostly used to create paper, toilet paper, maybe, or burnt. So we can say that we destroy our best forests of Europe and create, for example, toilet paper from these 400 years old trees, which is absolutely unbelievable. I spent a lot of time with studying the capercaillie, which is a nice species to show the overall patterns of old-growth forest biodiversity, at least in the Carpathians. It's a typical species of the spruce old-growth forests, and it's a well-known species, and we have a lot of data. We know quite well what it needs, what are its requirements. Just to briefly describe it. This bird, one single individual in average uses 550 hectares of suitable habitats. It's not a good flyer. It can fly usually between 5 to 10 kilometers. So the connectivity is really an important issue in protecting its population. And the minimum viable population requires between 250 to 500 kilometers square of suitable habitats. How the habitat looks like, you can see in this picture. So it's a forest with open canopy, with rich ground vegetation. It feeds on berries and insect, so it needs a lot of light in the forest, and also it's a big bird, so it needs to fly through the forest to hide from the predators, for example, under these low branch trees. So it's very important to have these low branch trees and light in the forest. So it's actually not that much what it needs. And this is how most of the old growth or primary forests look like in the spruce zone of the Carpathians. On the other hand, the commercially managed forests, the trees are planted too close, So we can see that the forest is too dense. So when the big bird flies through such forest, it immediately crashes into a tree, breaks its wings. So it's impossible to fly for him through such environment. You can see there is no ground vegetation, there are no berries, there is no light, no insect, and no hiding possibilities, especially in the clear cuts, which are also really not suitable habitat. It's a forest species. So it's just a basic description of the difference of primary between and commercially managed forests. What is important to mention that there is a lot of evidence recently that capercaillie benefit from recent beetle outbreaks, like you can see in this picture. This is from Bavarian forest, where the population was becoming extinct. Before the large-scale disturbance events, the population was around 120 individuals. After this forest changes, when many main canopy trees were killed by beetles, contrary to the expectations, the capercaillie population increased, and nowadays, as far as I know, is around 600 individuals. So actually, it's the only population in Czech Republic that is showing some increasing trend. We have similar observations from the Carpathian Mountains, where the best lake centers, the spots where the mating goes on, are found in these beetle outbreaks, like this one. So we created a model of the capercaillie habitats for the entire Carpathians. So the blue color shows where you can find them. If you'd like to see some capercaillies in the Carpathians, you can use this map. Most of the habitats represent old growth or natural forests, but we were also interested in the habitat loss, in the changes. So you can see the red color. The red color represents habitat loss. Especially here, you can see the A and B squares. So you can see there is a lot of red colors. So just to show you real pictures, this is what happened in Low Tatra Mountains. It's a national park. So since 2004, approximately 80 kilometers square of these suitable habitats, which are mostly old growth forests, were salvage logged. So actually this was legal. It's not illegal to do something like this in a national park in these countries. Similarly, in the borders with Ukraine, Romania and Ukraine, in the Maramuresh region, there is something similar going on. I was there during the most critical period, and it's just incredible to see these huge old trees fully covered with lichens that are taken out from this old growth forest. And yeah, you can see the capercaillies under the wheels of trucks. So it's just incredible. And in this table, you can see how much habitats were lost in protected areas like national parks. It was like 570 kilometers square. In special protected areas, almost 500 kilometers square. These are Natura 2000 sites, and in unprotected sites, 400 kilometers square. So in the protected areas, even more of the habitats were destroyed than in unprotected sites, which just highlights that the protection in this Eastern European system doesn't really work, and it doesn't mean that if something is a national park or Natura 2000 site, it will really help to protect the old growth forest species at all. So, as I mentioned, the connectivity is really important. So it's not only about habitat loss, but during the study period, I also need to highlight we used the data from 1985 to 2010. It's a little bit older study. So during this time, 15% of habitats was lost, and it decreased the connectivity by 30%. So it's even bigger problem, losing the connectivity for these metapopulation systems. And the trend continues. So now it's 2024. So if we would use more recent data, the numbers would be even more worrisome. Here I come back to the Western Carpathians. where we have better data also on the historical distribution. This is the distribution from 1970s. And you can see that the habitats were very well connected. The red, yellow, and orange colors show high connectivity of the habitat patches. And the dashed line, these are the least cost paths. So you can see that the population between these mountain ranges was very well connected, and it could communicate. The more recent data show dramatic decline in connectivity due to loss of these old growth forests. So we can see that the population became really fragmented and the habitats got too small. We conducted also a genetic study. You can see a map. Every dot is a sampled individual through feces or feathers, and the color shows belonging of this individual to genetically different subpopulation. So you can see every color is a different subpopulation. So the population is genetically fragmented within this mountain range. So it doesn't communicate well anymore, which most of you know that it's often the last step before the extinction. When you already show the genetic fragmentation, it's often like the last step to do something to change the trend. And of course, the population numbers reacted as well to the large-scale old-growth forest loss during this period. And the population decreased since 1972 by 76%. In special protected areas, Natura 2000 sites, which were designed to protect the species, it even became extinct in some of them already. What is even worse, that in the core zone, in the source population, there is this 50% decline. So yeah, it's difficult to say even if it's still possible to reverse these trends. Here again, some pictures of how this destruction looks like. So in the beginning, always are new forest roads to remote areas, to these old growth forest places which were inaccessible for a long time. And most of this logging is conducted as salvage logging. So it's just absolute misunderstanding of natural disturbance processes and the real like management and conservation systems. I would like to use just shortly these photographs to show how this salvage logging actually works, because the main reason is promoted is to protect the green forest, the green habitats, something like that, simply said. But this is an example, one of many examples. So we can see in 2004 where there was a wind throw. So salvage logging was allowed in this red polygon, which is old growth forest and capercaillie habitats. So you can see the salvage logging was conducted. There are some new patches. So the green forest should be saved, let's say. But you can see that in 2009, again, the salvage logging continues. Why is it so? These are really steep slopes. When you build new forest roads into such steep slopes, they often can change the water regime in the ground, in the soil, so the trees suffer from lack of water. They are stressed. Plus, you open the forest walls. You can see there are long forest walls, and the trunks of the trees, they reach a lot of sun. So these are ideal conditions for actually spreading the bark beetle. So what we can observe next in 2012, again, salvage logging, 2015 again, and 2018, you can see there is no forest left. So what we saved actually is wood, yes, but this is the national park, and it's in the core zone of the capercaillie population, which is a priority species of Natura 2000 sites designed to protect these habitats. And yeah, here you can see again the scale. As I mentioned, this happened, for example, in this Low Tatra Mountains at scale of 80 kilometers square. So it's really huge. often, as Ria mentioned, we mapped in Slovakia all the primary forests using quite strict definitions, especially on the historic impact. And we use this definition to map the primary forest and to protect this forest based on these strict definitions. But what is the result? You can see this is a protected primary forest, but I will use again the Capercaillis. It was all this place before there was this huge clear cuts. It was the best lake center in Low Tatra Mountains. So you could count in one place always around 10 Capercaillie males. But then after this large-scale logging was protected, just because we didn't protect entire area, but only this strict definition, the Capercaillie numbers didn't decrease immediately. It took some time. So after 3 or 4 years, you could still find there 8 to 10 Capercaillies. There was not like dramatic decline, but after 6, 7, 8 years, there were only four Capercaillies and 3. And nowadays, 15 years since the logging, there is only 1. So there is ongoing extinction depth. So despite we protected these primary forests, we actually didn't help the biodiversity because the species are extinct from these little fragments. Here are some other examples. So using this type of definitions and protecting only definition doesn't really help the biodiversity. But we have also good examples. This is Ticha and Koprova Valley, which is actually a case study in the Wild E project. These yellow polygons are the primary forests where you can find these 1,000-year-old pine trees. But luckily, especially thanks to the public pressure, these primary forests were protected within entire valley systems. And what we can observe that in the bottoms of the valley, there was a natural disturbance which remained unsalvaged. Species from the primary forest are migrating and colonizing this area, including lichens, capercaillies, or tree species. So here, in this case, really the primary forests serve as a source populations and donate the surrounding environment, which is being rewilded through disturbances. So this is actually how we believe the primary forest reserves should be designed. So yeah, just to conclude this, natural disturbances such as wind throws and bark beetle outbreaks are natural part of the forest dynamics that support and maintain biodiversity. They create this mosaic structure, which is really important for different groups of species. Conservation of primary forests and old growth forests in Europe is very slow. Many forests are still not mapped. Many primary forests are not protected. And this trend, at least to our experience, is not really changing much. Of course, conservation of only primary forests is insufficient. So that's really important to consider also the rewilding. But what is strange that we are even not able to protect what we have. And yeah, on the other hand, we still need to rewild, not leave the species to suffer by extinction depth. Okay, so I think that's it.
Thank you, Martin, and thank you, Rhiannon. Super interesting. We would actually like to hear a few opinions from everyone in attendance today. And for that session, we use a tool that's called Mentimeter. And if you haven't used Mentimeter before, it's very easy to use. Just scan the code or use the link and use the code that's here on the screen or in the chat. You don't need an account or anything, but there are a few questions there that we would like you to answer. So please go to menti.com, enter this code, and answer the questions there. And let's just give everyone a minute to get signed up and answer the first question. James, could you please show us the first questions to see if we already have some answers actually coming in? So the question is, to what extent do you agree that primary forests and other wilderness areas are adequately protected? We see some questions coming in so far. It's a bit of a mix, but Martin, what do you think yourself? I think from your presentation we might get some. We're getting now more and more strongly disagree and disagree. Do you think this is in line with your thinking as well?
Yeah, I would strongly disagree, definitely, that it's a real problem. So we really protect too little, and of course it's not sufficient to protect only primary and old growth forests, but even in this like kind of small, relatively small objective to protect few percent of the landscape, we are just not able to do it, and I don't see like a real fast solution like.
And although you've provided some interesting solutions, also with the design, so there is some hope there still too. Rhiannon, what do you think? Do we have in the future some tools to protect primary forest better than we do currently?
I mean, technically we have the tools to protect them, right? But the government of each country is quite slow to implement these tools. We know that there are many rare species which rely on this habitat connectivity across the landscape. We know that many of these species, such as the capercaillie, are endangered or even going extinct in some areas, but still it's still very slow to protect wider areas, and this is mostly due to economic interest. You could say that the salvage logging is driven by the fear that the timber will go to waste, or so it's in the interest of the people controlling the landscape to take the timber out. But we know from this research that we need to keep it in the landscape. So we will see how this will change with the regulations in the future. Hopefully for the better.
So for everyone, if you have additional questions, please put them in the chat, and maybe James, we can move to the next question coming in.
Yeah, maybe I would just add to the tools, because I don't think we have all the tools actually available that could be. Even it's really a big problem to get, for example, funding for just simple mapping of these primary forests and old growth forests. Most of these forests are still not mapped. So there are some maps, but they rely only on some information that is available from different studies. But it's really difficult even to get funding for mapping itself. And for protecting these forests, there is often distrust also of local managers and stakeholders in the state government and getting their compensation, especially in the Eastern Europe. So I think there is plenty of work actually to create tools to do this, including the funding of mapping and especially protecting these sites. Because as we mentioned, it's also a lot about money for these people.
Yeah, this is what I meant by tools as well. Like we actually do have the money on the European scale, right? But it's just not distributed towards these efforts. So yeah, we're lacking the research possibilities because of this.
Thank you for that addition, Martin and Rhiannon. For this question that's on the screen right now, is there a correct answer to these ones, or are all of them ones correct? Or what would you say is the answer to this?
I would say the first one is the correct answer. Savage logging of natural disturbances leads to the largest destruction of these natural habitats and loss of the species we often want to protect. On the other hand, protecting the primary forests using this strict definition, as I try to show, results in protecting very small fragments, which are often in Europe like of size of 20, 30, 40 hectares, which is nothing. Only consider the capercaillie, which requires 550 hectares, one species. So, and similar habitat requirements have other populations which are much more even dependent on these old growth forest structures. So primary forest protection by itself will not really help us to support the forest biodiversity and especially the rare species. We need to connect this and create larger source populations.
Makes a lot of sense, and that's a clear message. Perhaps the last question of the three that we had here. We have the question, how does strict protection following natural disturbance minimize forest structural homogenization? And Martin, maybe you could quickly say what you mean with homogenization for those that might not be from a forestry background in the audience.
So homogenization of age structure, tree species. So there is a lot of discussion, at least in disturbance ecology, that the natural disturbance may lead and homogenize the landscapes, especially when it's a large-scale disturbance.
Makes sense. Rhiannon, you see the answers coming in. What do you think? To me, they all sound like good answers.
Yeah, this was a trick question because actually all of the answers are correct. When we strictly protect a landscape after a disturbance rather than salvage log, it's through multiple pathways. The diversity of the forest structure is increased. So because of this development, different tree species will grow, and this will increase the species heterogeneity of the canopy layer and produce different types of deadwood and other specific structures. And all of this contributes to the diversification of forests, which is very important for the species.
Very interesting. I think we have one or two questions. So if there's any other questions, please put them in the chat. But the first one, you've already alluded to it a bit, is the question is, why is the Romanian government resisting to recognize primary forest? And does this same trend actually happen in other countries as well?
So, of course, it's not only Romanian government. We observe this pattern in many other countries, including Slovakia, although we have protected the primary forests, but still the old growth forests and many natural habitats are not protected. Slovakia lost court with European Commission because of destroying the habitats of capercaillie just recently. Why the governments are resistant? This is not. I cannot answer this. I don't understand it because often it's a proportion of the landscape. We don't say. Nobody says, even like the most radical conservationists never said that we have to protect everything, all the forest. It's just small percentage of all the landscape, which is mostly the like best habitats that are left. So I don't know. Yeah, I really don't know. It's probably for different scientific field, not for ecology, but it's more for maybe social science or psychology. I don't know, to be honest. But of course, the tools, we need more tools to protect. So I would expect, for example, European Union to provide some direct fund to independently map all the old growth forests when we want to protect them. I didn't see nothing like that. And also to provide some better tools to compensate for this strict conservation. And I hope this is something what will follow in the next years. But time is passing, so.
An interesting question that came in here now, it's something that's talked a lot in the rewilding paradigm as well, is do you think the release of large grazing animals helps to develop these primary forests and provide some disturbances? How do you look upon these large animal release in the Carpathians?
So I personally don't study the large herbivores effect on forests yet, But in my opinion, yes, definitely, this is an important natural disturbance. And this presentation was especially about the mountain forest, where the disturbance agents such as beetle outbreaks, windthrow are still present. But for example, when we go down to the lowland forests, where you don't have large herbivores and you don't have floods, so even if you strictly protect these sites, you might be losing the biodiversity there because you don't have there this historical natural disturbance regime. So yes, I definitely believe large herbivores are important drivers, and would be really interesting to do more studies even in the mountain landscape. Just recently, for example, the European bisons were released in the Fagaraj Mountains, so there is a nice herb of European bisons that you can find in the mixed mountain beach-dominated old-growth forest. It's really wonderful. So we will see. But yeah, definitely, it's an important aspect.
Interesting, and definitely something other people in the Wildy project are working on. So maybe in a later presentation, we will talk a bit more about that as well. I have a question here that asks about the EU biodiversity strategy and forest strategy, and they're very explicit concerning strict protection of all primary forests by 2030. Have you some hope that this might help to reduce salvage logging, this new legislation, where the national park status not yet has helped?
Yeah, of course, first we need to map all these primary forests and old growth forests. And yes, so if these forests are strictly protected, then definitely it will help. But the issue is that many of these sites are protected only in like form of Natura 2000 sites, which doesn't um, force the owners or state to strictly protect. So actually, their own national law forces them to conduct salvage logging legally in Natura 2000 sites. So first step is to map these sites, but then to strictly protect through some like really strict protection in terms of strict reserves or core zones of national parks. But yeah, I believe this could definitely help. But I mean the European biodiversity strategy, but I just see the realization is too slow. So I don't believe we will manage, although I would love to believe that.
We are nearly at the end of this webinar. Just a last question for Rhiannon. We've been talking about some of the very interesting, but also some depressing presentations. To end this off on a bit of hope, do you see any signs, maybe in support of local people living in the areas or others, that things might improve still in the coming period before it maybe is too late?
For the local people, uh, I think yes, I think this can be really beneficial for local people. We have example, Ria showed the Bojamika Valley, which is this 10-kilometer long valley without road, without trail actually, where even the forest owners have never been there. And it's privately owned. And the main reason, it took like 7 years, but the main reason why the owners agreed to protect it, it was because their village, the young people were leaving their village, so they were searching for some kind of tourist attraction. And when all the professors from Western Europe came to this valley and showed to the forest owners how amazing it is, they realized it's better than to destroy it, to protect it. So this is kind of nice story where they get compensation. They have some local hotels. So hopefully this is the place where it will help the local communities. And I think there are many places like this where people are leaving the villages, and something like this is probably the only way how to actually help these people in the region.
Thank, thank you all so much for here. I think we answered all the questions, but we will go through the chat otherwise to make sure that the last questions are answered afterwards. Um, Martin, Rhiannon, thank you so much for your presentation. Super interesting. And thank you everyone who's attending. And we look forward to seeing you at the future Green Shoots webinar when we'll show more about all the work we do in Wildy. Thank you so much, everyone.
Thank you. Bye bye.
Thank you. Have a nice day.